Alright, let's look at this example we have. We're given a copper alloy. This alloy has Young's modulus of 110 gigapascal. And if we apply a tension load, sigma equals 200 megapascal to this alloy, and the original length of the alloy is 300 millimeters. We want to find out what is the resultant elongation delta L when you apply this tension load. And we assume the deformation is entirely elastic. And the second thing we need to find out is what's the total length when the load sigma is applied. And the third thing we want to find out is what is the total length L2 when the load is released. Okay, let's work together to see how to solve this problem. Let's solve the first problem first. And we want to find out what is the resultant elongation delta L. And from here, since this assumption is very important, if the deformation is entirely elastic, that means we can apply Hooke's law. Remember the Hooke's law? The stress sigma equals epsilon, that's a strain, times Young's modulus. That means if we only have elastic deformation, we can apply this equation. And in this case, we're able to apply this equation. So here we know E, Young's modulus here, equals 110. We can convert gigapascal to pascal, that is 10 to the 9th order pascal. And strain sigma is epsilon is something we try to find here, so that's the unknown. And the sigma here, it's the tension we apply to the alloy, which is 200 megapascal. We can convert that to pascal, 10 to the 6th pascal. Alright, seems like the strain is the only unknown, so we can put strain on one side of the equation. And we have sigma divided by E. And we can find out what is the strain under this given tension load. Tension is 200 times 10 to the 6th divided by 110 times 10 to the 9th. Here's pascal, pascal. So unit cancels off. We end up find out the strain is 8.0018. That's the strain under this tension load. Okay, so far we solved. No, we haven't solved the first question yet, since here we're looking for what is the resultant elongation delta L. We're one step away from delta L since we already know the strain. Remember, what's the definition of strain? Strain equals delta L divided by the original length. Here, we do know what is original length. We know the strain. Delta L is only unknown. We can solve delta L. Delta L equals epsilon times L0. Here we have 0.0018 times the original length, which is 300 millimeter. Okay, and we can find out the resultant elongation. It's 0.545. The unit is millimeter. And this is the result for the first question we have, the resultant elongation. Okay. Now we can look at the second question. The second question is not too hard. And we just want to find the total length under the load. And we know what is the change of length. We know the original length. So the total length under the load L1 is going to be just L0 plus delta L. In this case, the answer is going to be 300.545 millimeter. Right. Now let's look at the third question. What's the total length L2 when the load is released? Okay, and I want you to think about what should be the total length after you release the load. What happens when you release the load? You know, the alloy will try to recover to its original shape, but how much it will recover? And here, this sentence gives you a very important hint. The deformation is entirely elastic. Therefore, um, it will recover 100%. That tells you once you the load release and L2 gonna equal L0, which is 300 millimeter, due to the